What if there was a galaxy that just never got started? A kind of cosmic ghost hiding out in space? Well, that's pretty much what astronomers stumbled upon way out in the Canes-Venatici constellation, over 14 million light-years from home. They were looking at a pretty famous galaxy, M94, when they noticed something else nearby, something massive but completely invisible. This is the story of Cloud-9 and the hunt for a galaxy that just failed to be.
So, it all started when radio telescopes picked up this enormous blob of hydrogen gas, which you can see here in red. Now, this thing has the mass of about 1 million suns, so, the next logical step was to point the Hubble Space Telescope right at it. The expectation? To find a faint little galaxy, a small cluster of stars. But when the pictures came back from Hubble, there was nothing. I mean, almost nothing. The gas was clearly there, but where were all the stars?
All right, so let's start digging into this mystery. What exactly is this starless cloud, and why is the fact that it's so empty completely fascinating to astronomers?
Okay, so let's get the basic stats on Cloud-9. It's hanging out near galaxy M94, and it's packed with 1 million suns worth of gas. But here's the really weird part. It's dynamically cold, and it's not rotating. That basically means the gas isn't swirling around, collapsing, and forming a star-making factory like in a normal galaxy. It's just hanging there, held together by some force we can't see.
Now you might be thinking, okay, it's a gas cloud. So what? What's the big deal? Well, the thing is, finding a cloud with this much mass and absolutely no stars, it kind of throws a wrench into the rulebook for how we thought the entire universe was put together.
And that rulebook has a name. The Lambda Cold Dark Matter Model, or Lambda CDM for short. Just think of it as the standard blueprint for the cosmos. It tells us that the universe is built on this invisible scaffolding of dark matter. And these dark matter halos are basically the seeds where gravity can grab onto gas and start building the stars and galaxies that we see today.
But here's the really fascinating part. This same model has been predicting for a long time that there should be tons of these smaller dark matter halos out there that just weren't quite massive enough to really get star formation going. They'd managed to collect a bunch of gas, but then they'd just fizzle out. They would become, for all intents and purposes, these failed or ghost galaxies. For decades, though, this was just a theory.
So, you can see where this is going. With this amazing prediction in hand, scientists suddenly had a prime suspect. Could Cloud-9 actually be the proof they'd been looking for all this time?
The mission was simple, but it was a big one. Take the most powerful telescope we have, Hubble, and just stare, for a long, long time, deep into the heart of Cloud-9. They weren't just looking for random specks of light. They were hunting for the faint, ancient glow of stars that would finally prove a galaxy, no matter how tiny, was hiding inside all that gas.
And you can't just look blindly, right? You need a benchmark. So to know what they were looking for, they used a perfect comparison. This little dwarf galaxy called Leo T. It has about the same amount of gas as Cloud-9, but it actually succeeded in making stars. So the question was really simple. Would Cloud-9 look like Leo T? Or would it look like nothing at all?
So, what did Hubble see? Well, this is the best part of the story. The truth is, what it didn't see was the really mind-blowing part.
And this slide just says it all. On the left, you've got a simulation of what a tiny dwarf galaxy should look like in an image like this. It's faint, but it's definitely there. And on the right, that's the actual Hubble picture of Cloud-9. It's empty. The ghost wasn't just a theory anymore.
I mean, they went over every single pixel of that image, and the conclusion was totally inescapable. There were no stars, no hidden galaxy, just a huge, lonely cloud of gas held together by dark matter.
Which brings us to this number, greater than 443. Now, I know it just looks like a number on a screen, but in cosmology, a number this big is the absolute smoking gun. It's practically screaming at you.
So what is it? It's the ratio of gas to stars. In a normal, gas-rich little galaxy like our comparison Leo T, for every, say, 4 pounds of gas, you get at least 1 pound of stars. The ratio is less than 4. In Cloud-9, that ratio is more than 443 to 1. It is just wildly, unbelievably star-poor.
This all pointed scientists to one prime suspect, something called a RELHIC halo. Yeah, it's a bit of a mouthful, I know, but the idea behind it is just beautiful.
It's a dark matter halo that was big enough to grab onto its gas, but just not quite big enough to fight off the intense radiation from the universe's first stars and actually kickstart its own star formation. It is, basically, the textbook definition of a failed galaxy.
So, they have their suspect. But in good science, you can't just stop there. You have to rule out every other possibility before you can be sure you've really found a cosmic ghost.
And they considered everything. Could it just be a random cloud in our own galaxy that happens to line up? Nope, its speed is a perfect match for the M94 galaxy system, not ours. Okay, what about a piece torn off another galaxy? Wrong side of the sky for that. Well, maybe it's just a temporary puff of gas. Super unlikely? Without a dark matter halo holding it all together, it would have just blown away ages ago. Every other explanation just didn't work.
And this chart really drives the point home. It shows just how unique Cloud-9 is. If you plotted thousands of known galaxies based on their stars and gas, they'd all bunch together down at the bottom. And then, way, way up at the top, completely in a league of its own, you see that red star. That's Cloud-9. It's a true cosmic outlier. The researchers who published this study, they put it perfectly. They said, Cloud-9 thus appears to be the first known system that clearly signals this predicted transition between failed and successful galaxy formation. This isn't just a cool discovery, it's a major confirmation of a huge piece of modern cosmology. But a discovery like this, it doesn't just close a case file. If anything, it opens up an entirely new mystery for us to explore. So, why does all this matter? It matters because finding Cloud-9 confirms a really fundamental piece of that cosmic blueprint we talked about. It shows us that these dark matter halos are real and that the line between a brilliant star-filled galaxy and a failed dark ghost can be incredibly thin.
And the story is far from over. The next step, of course, is to point the even more powerful James Webb Space Telescope at Cloud-9 to see if we can find anything at all. Scientists are also going to run new computer simulations and search for other faint signals that could actually help them map out the shape of the invisible dark matter halo itself.
Which really leaves us with one final, just incredible question. For all of human history, we could only see the successful galaxies, the bright ones. Now we know the failures are out there too. So if Cloud-9 is just the very first one we've managed to confirm, how many countless others are still out there hiding in the dark?